Hello, welcome back to the Looc. In this section, we are going to look at arrays, how to use arrays, how to declare and initialize arrays, how to use the for each iteration statement, and other concepts related to arrays. Arrays are an example of data structures that are collections to store related data items, and in case of arrays, the data being stored are of the same type. They are also fixed length entities, so once they are created, their length remains the same. There are other data structures then that can work better than this, whose length is not fixed and can store all kind of different types of data, but arrays are the simplest ones. So we can think of them as a group of variables called elements that contain values of the same type. They are also reference types, meaning that they are like objects. In other words, when they are parsed, the original object is parsed and can be changed by the receiving functions. And the elements themselves can be value types or reference types. To refer to a particular element, we use a subscript or index, which is an integer. It basically enumerates the elements of the array. So here is what an array would look like when stored in memory. So the name of the array is C, so it's a variable that contains multiple values, and its first element is -45, its second element of 6, and so on. The numbers 0, 1, 2, 3, and so on all the way to 11 are the index or subscript values in the array C. Note that I refer to the first element as -45 being the first element, even though its subscript is 0, and the second element, 6, has a subscript of 1. So the subscript is 1 less than the colloquial term we use to refer them as first, second, third. In other words, arrays are so-called zero-based. In other words, they are not 1-based, so the subscript don't start counting from 1 like 1, 2, 3, 4. They start counting from 0, 0, 1, 2, 3, 4. And therefore the first element of the array is really the 0th element, and the second element is really would be the 1th element, and so on. So the subscript is 1 less than the way we refer to them. We can have access to the elements of the array using something called an array access expression, in particular square brackets that surround the subscript or index that we are looking at. So the first element has an index 0, and the 0th element you refer to as first, but it's really the 0th, and the index is a non-negative integer and can be an expression that evaluates to a non-negative integer. And every array has a length, and it's stored in its length, capital L, length property. Since they are objects, they are typically created with the keyword new, so in effect we are implicitly invoking a constructor, and the number of elements of an array is typically specified in an array creation or declaration expression. So here is an example of it. We are going to declare an array that has elements that are of type integer, and we will call it C, and the syntax int square brackets C equals new int square brackets 12 shows that this will be an array whose length is 12. It will have 12 elements, and the types of the elements are integers. The name of the array is C. that there are 12 elements also means that the subscripts are automatically 0, 1, 2, 3 all the way to 11. Not 12, 11 because we start from 0. So that syntax can be broken up into two steps. It doesn't have to be written or sit on a single line. So we can just declare int square brackets c. So we declared a variable c as before. Without the square brackets, c would be just an integer. The square brackets after the int indicate that c is actually an array of integers. And then we specify the size and actually create it by invoking the new keyword. So c equals new int 12. We create the array and the variable c, which was declared to be the appropriate type, will reference to the new array. And it will have 12 elements. It also can be calculated in execution time, the number of elements in the array. And depending on the type, each element is defaulted numerical values to 0, booleans to false, and references to null. This is typical for all kind of objects. And we shouldn't put the 12 after the int right directly, because that would be a syntax error. So int followed by square brackets is the type of the array. Number of elements is declared on the other side after the new keyword. Several arrays can be created in a single declaration. However, it's better to separate each declaration to its own line. And we can create value type or reference type element arrays, and generally, as in C#, if something is of a native type or primitive type, such as a numerical type int, they are value type elements, and if they are objects such as string, then they are reference type elements. There is a static resize method that can change the length of it, even though normally they are fixed. However, it takes time because it actually amounts to creating a new array with a new length and copying the elements from the old array into it. And if the old array was longer than the new, then the leftover elements are disposed of without warning. So here is a program that shows the creation and use of an array. It's called initArray, has a main method, and first we declare an integer array type variable called array. Then in the second line after the comment, we initialize it, meaning we create a new array of size 5 integers, and we assign this new array to be referred to by the variable name array. Then we are writing a write line where we are preparing the output, and then we output the array elements in a for loop. For int counter refers to the loop variable starting at 0. Keep looping until as long as the counter is less than the length of the array, and increment the counter every time, and then place a console write line in which we are print out both the counter and the element of the array. Here is what the output will look like since we didn't assign any new elements to it. Note also that we also specify the length of the various outputs, So on the right line, we the first variable index is our first argument and the second value is our second argument, and that will be 8 characters wide when printed. And following that, in the console right line for the contents itself, the counter values will be our first or 0th argument printed 5 character wise, and the array contents printed 8 character wide. That just corresponds to the fact that index is 5 letters wide and we want them to be right justified as it is. So when we specify a length, then the display will be right justified within that length. If we want it to be left justified, we have to use a negative number. So let's write this program first. So here is C# Express, and there is an application called Array Test App. It's right here, and it has a program file arraytests.cs, and this is where we are going to write all our programs. So for the very first one, we start up as before, and then first we create an integer type array, and it's just called array. So if we want to comment this, this would be declare a named declare an array named array, and then we are going to initialize it. So this will be initialize array, which means that create space for array and let it be initialized to be all zeros. So our variable name is array, and the new keyword indicates that we are creating a new object, and it will be an array of element size 5. It's not necessary to leave spaces around the length of the array, but it makes it easier to read. So this is 5 integer type elements, and then we are going to print out our title line, so it will be console write line, and our template string is the first argument first, followed by the second argument, 8 characters wide, and the first is a string index, and the second, oh, that's not what I wanted, index, and the second is called value. To override IntelliSense here. So these are our headings, and I have to go back and close my formatting string here, and then we are going to output each array element's value in a for loop. So for, here is the loop counter variable, counter equals 0 as long as counter less than the array's length. note it has to be less than, because the subscripts run from 0 to 4 for a 5-element array, and the length is 5. So as long as it's strictly less than, and then we can increment the counter. It doesn't matter whether we use prescript or postscript, pre-increment or post-increment. It works, and console write line, and here we are going to print out our 0th, let's call it that way, 0th output, actually 5 long, followed by the next argument 8 spaces wide, and that's the format thing, and we want to print out the counter variable itself, and then the value of the array elements, namely the one that we are accessing using the counter. And that's the end of the write line. When we are here, this is the end of method main, and here we are end of class array tests. There. So note that the for loop has to be correctly set up, and the initialization condition, the exit condition, and the incrementation are separated by semicolons, and that takes care of it. So let's try to build this. And it is showing an error, and the error is that I used the wrong kind of brace there. So let's try to build this, and if it succeeded, after I corrected the 4, of course, has round parentheses, not curly ones, we can try to run the program with Control F5. So with Control F5, and here is the output, the elements of the array, moving it down here, displayed. So all of them are 0, because we didn't say otherwise. So when we create a new array and we don't say otherwise, its elements are initialized to the default values, which in case of numerical values are zeros, in case of booleans it's false, and in case of objects it's null. So that was our first try to create an array. That's the program that we just wrote. However, we can use an array a little bit, we can initialize an array differently. Namely, we can give specific elements as the elements of the array. And in that case, we don't even have to specify the lengths, but it will be implied simply by how many elements we type in. So here is a program showing that the initializer list that specifies the value of each element. So array again is an integer array type, and then instead of writing a new keyword and specifying that we are creating a new integer array, we simply in curly braces list the elements that make up the array, and the length will be automatically determined. In this case it is for plus 10 elements, and we display them as before. So let's do this. We have to just slightly modify our previous program, which is not there but here. So this is how we wrote the first time. So the change we really need to do is initializing the elements, except in this case we use an initializer list that specifies the value of each element, and as a result we don't need to specify directly how many elements will be in it, because simply by creating the array it will be determined, and we don't need a new keyword. So this time, say the numbers are 30 to 27 and so on, or random numbers that don't really have to follow any particular pattern. In this case, you can think of it as, I don't know, scores or something, because they are all less than 100. So could be scores on a test or something like that. So and they are within curly braces, and that's the array, except that we don't even need to declare first, but we can declare it right where we initialize it. So we can say that this is an integer array of that type. An integer array made up of those elements. Check the parentheses again, and let's see what exactly is what the problem seems to be here. Why is it giving me problems? Because it's misspelled. That's one reason. So it's int array. So that's our array, and we are ready to, oops, shouldn't have changed that. We don't really need to change the headings or the output at all. So that's our new version of the program. And just save it, and let's build this, and Control F5 to run it. And here it comes. So this time it's displaying all the elements, all the elements from our array, and they are not all zeros. So this time we use an initializer list instead of the new keyword, and using default initialization. So there's the second version of our program. And the outputs. As another example, we can calculate values that go in an element, and we can use constants, but they have to be initialized when they are declared and cannot be modified later, and we call them named constants. So here is the example of the program that uses that. So a const int, so it will be integer. It's like a variable, except unlike variables, it cannot change their values, so we declare them with the const keyword, const int array length equals 10, and then we create a named constant. Now we could use the number 10 directly in the next line when we declare an array, integer array, new int, and the length in it. We could, instead of array length, just put the number 10 directly in it, but it's not a good idea, because those are so-called magic number. That would be a so-called magic number that doesn't really explains what its purpose is and why is it the value it is. So it's better to use named constants like array underscore length. And the other advantage that if we want to change it later to a different value, then we have to change it only at one point if it's used in a long program many times, instead of every single time changing number 10 to something else. Other than that, we have again a for loop, except this time the elements of the array are calculated by some expression. In this case it's double the counter and adds 2 to it. There's no particular reason, just to illustrate an expression that calculates the value of the elements of an array. And then we are going to display it as before. There are no headings. There is a heading. There's the heading. So there's no change in the output. And this is what the output will look like. So let's modify the program we have to this particular example. So again, the changes in how we declare and create the elements of the array. We want to create a constant int called array underscore length, and we set it to 10. So here we created a named constant. And then we create the array itself. So int array, and in this case, since we are not initializing it directly, we use the new keyword as before, and the length of the array is array length, which IntelliSense gives us right away. So this will be except it should be lowercase array, because the uppercase array is a reserved word, so we cannot use that. In this case we create the array itself, and again there's a typo there, int. It's my keyboard doesn't always, it's a little loose, doesn't always type a letter that I think I type, or the one I intend to type. And then we are going to calculate the value for each array element. So it's a for loop, and again we use a counter variable initialized to 0, as arrays are index 0 based, and the counter again has to stay as long as it's less than the length of the array. We continue the repetitions and pre-incrementing the counter variable, and a single line of body, the actual computation of the appropriate element of the array, which is 2 plus 2 times the counter value, just because that's what we want. The rest of it doesn't need to change. So let's save this version and let's try to build it. And once it's succeeded, we can run it with F5, and here are the values that the calculation creates. So again, this time we calculated the values of the array by doubling the counter and adding 2 to it. So when the index is 0, the value is 2, when this is 1, the value is 4, and so on. In essence, the even numbers from 2 to 20, and those are displayed. So that's our output, and again that's the output that we just saw. we know that we cannot change a named constant, and also we have to initialize it before using them. And again, it's a good idea to use them because they indicate their purpose, and if we want to change it and it used many times, we have to change it only in one line of the code instead of going through and try to hunt down. In general, it's not a good idea to use the so-called magic numbers that just appear in the code without any explanation why they are what they are, like 10. Why is it exactly 10? If there is no particular reason for it, then we just give it a name and set it to 10, and then if we need something else, we can set it to something else, but in the code itself, they don't appear just out of the blue. So that's the end of this segment, and the next segment we continue looking at arrays in more detail.